So we want to compute derivative of two functions multiplied. In particular, we have cube root of x squared and ex multiplied together, and we want to compute the derivative of it. So until now, we have seen how to do the derivative of two functions when added or subtracted. And now we want to basically embark on how to do derivative of two functions multiplied. So how do we do this? Now, if we had some way to relate it to, so if we had some way to relate it to cube root of x squared to derivative of cube root of x squared and derivative of e to the x, we would be basically done, right? Because we know how to compute derivative of cube root of x squared and e to the power x. Okay. So let's see. So first of all, derivative of fx times derivative of g of x is not equal to derivative of f of x times derivative of g of x. So the product rule does not simplify, or in other words, you do not have fx gx prime equals to f prime x times g prime x. So this is not true in general, right? Let's see an example for this. So the example is, take f of x equals to, say, x, g of x also as x. In that case, we have fx times g of x is going to be what? X times x, which is x squared, right? So we have if we take derivative of that, that is going to be 2x, right? But on the other hand, we have f prime x times g prime x. So what is f prime x? Derivative of x is 1, and derivative of g of x is also 1. So this is 1, and clearly these two guys are not equal. Okay, so derivative of fx gx is not derivative of f times derivative of g. Okay, so what is it then? All right, so for that we have the following rule. Derivative of fx gx is fx times derivative of gx plus gx times derivative of f of x. Okay, let's see why is that the case. So we want to compute fx gx prime. Now, using the limit definition, so whenever we are trying to come up with a new formula, we have to use the limit definition. So limit as h goes to 0, f of x plus h times g of x plus h minus fx gx over h. So if you are able to compute this limit, you have already computed the derivative, all right? But however, this does not brings in, so derivative of f times g is going to be this limit. However, this limit does not reflect the derivative of f and derivative of g. So what we want to do is, not only we want to find out an expression for derivative here, we want to find a derivative of f times g in terms of derivative of f and derivative of g and functions f and g themselves. So what we'll do is the following. I will try to convert into so let's add and subtract fx times g of x plus h, fx times g of x plus h minus fx gx. And divide the whole thing. Now here, you can from the first two, you can take g of x plus h common. So you have g of x plus h. What is left in the bracket? Fx plus h minus f of x. And then you're dividing the whole thing by h. I will distribute that h here. Similarly here as well, you will have limit as h goes to 0. Take fx common. And in bracket, you'll have g of x plus h minus g of x over h. Yeah. So what do you get out of that? Now g is a continuous function because it's differentiable. So you'll get limit as h goes to 0, g of x plus h equals to g of x. This will be your f prime x plus f of x times g prime x. So this is how the derivative is computed, right? So easy way to write down derivative of f and g is you take fx gx and you want to compute the prime of this. That is going to be write the both things twice. So you write fx gx plus fx gx and you distribute the prime. First you can give it to f prime, sorry, to f, the next you can give it to g. All right. So let's differentiate this. So now in this case, the derivative of f of x, I'll write it as f prime, is going to be first function as it is times derivative of the second function plus e to the x times derivative of the first function. Now here, derivative of e to the power x is e to the power x plus e to power x times derivative of x to the power, there's a power 2 missing here. This is what, note that here, cube root of x squared is same as x to the power 2 over 3, right? So we get what? We get, this is going to be, using power rule, 2 by 3 times x to the power 2 by 3 minus 1, which is minus 1 by 3. So this is your derivative. So again, in this case, I will use the prime notation. So g prime x is going to be x plus 1 prime 2x squared minus x plus 1 plus x plus 1 times 2x squared minus x plus 1 prime. Okay. So x plus 1 prime, so derivative of x is 1, derivative of 1 is 0, so this is going to be 1 times 2x squared minus x plus 1 plus x plus 1 times derivative of 2x squared is going to be, so I have to use the sum rule here. So this is going to be 4x. Derivative of x is 1. So we get this is your derivative. Okay. So this is how you deal with derivative of products. Now the next rule we want to discuss is the quotient rule. So quotient rule, again, you can derive it using limit. So you can come to this formula by doing the same thing. Limit as h goes to 0, f of x plus h minus f of x, sorry, divided by g of x plus h minus f of x divided by g of x, the whole divided by h. Yeah. And then you cross multiply. Right? Then you have to again add and subtract something. So you can add and subtract. So add and subtract. So what do you have to add and subtract? You have to add and subtract what f of x times g of x. And then you will get the answer. All right. So we'll leave the derivation there. You can finish it. Let's just do this. So add and subtract this. So we get what this is going to be. Limit as h goes to 0. What is f of x plus h? So we get, when I add and subtract this guy, I get f of x plus h minus f of x times g of x plus f of x times g of x minus f of x times g of x plus h, the whole thing divided by g of x plus h times g of x times h. Now I'll do the same thing. I will distribute the h. The limit as h goes to 0. Take, here there's g of x missing. I'll take g of x common from the first one. So I get g of x in bracket f of x plus h minus f of x. And now from the second one, I will take minus fx common because I want to write it as g of x plus h. There's a minus sign here, right? So I'll do g of x plus h minus g of x, the whole divided by h times g of x plus h times g of x. Now what we can do is limit as h goes to 0, g of x times f of x plus h minus f of x. I'll give this h here, minus f of x times g of x plus h minus g of x over h, the whole divided by g of x plus h times g of x. Now limit as h goes to 0 of this guy. So g is continuous at x, so you'll get g of x times, this is going to be, this part is going to be derivative of f. So f prime minus f of x times g prime divided by g squared. So this is how the quotient rule comes into the picture. Okay. So now let's apply the quotient rule to do the following problem. So we have y equals to 2t square minus 1 upon t cube plus 1. So we want to compute dy by dt. So again, you can use either one of the notation. I generally prefer d by dt notation, but it's up to you. So denominator square, denominator as it is, times d by dt of 2t square minus 1 minus 2t square minus 1 times d by dt of t cube plus 1, the denominator. So this is the quotient rule. Okay. Now what do you get? So t cube plus 1 times 4t, right? Because derivative of 2t square is what? 2 times 2t, which is 4t, minus 2t square minus 1 times derivative of t cube plus 1, which is 3t square, the whole divided by t cube plus 1, the whole square. Yeah. So now your derivative is done. If you want to simplify, you can go ahead and simplify it. Now, how about f of x equals to e to the power minus x? So first of all, you may ask, where is the quotient rule? So this is same as 1 upon e to the power x. Now note that there are some other methods which you'll learn later, namely the chain rule, with which you'll be able to differentiate it directly without using quotient rule. But for now, let's use the quotient rule. So again, f prime x is going to be denominator square, denominator as it is, times derivative of numerator, which is 1, minus numerator times derivative of denominator. Now derivative of 1 is 0, so this is going to be 0 minus 1 times derivative of e to the x is e to the x divided by e to the x the whole square. So what do we get in this case? When we divide, you'll see we get minus e to the x upon e to the x square. You can cancel 1 e to the x off. You'll get what? Minus 1 upon e to the power x. And if you want to write it on the top, you can write it as minus e to the power minus x. So this is how the derivative of f of x, which is e to the power minus x, works. Okay. So for good, let's move on to the next problem. So here in this case, you are given f of 3 is 4, g of 3 is 2, f prime 3 is minus 6, g prime 3 is 5. Find the following numbers, f plus g prime of 3. Now note that in this case, you're not given the function, right? You have said that f and g are such functions that at these points, these are the values, and you have to compute the values. So let's see. So first one, we have to employ the sum rule. So this is going to be f prime of 3 plus g prime of 3. Now let's see, what is f prime of 3? F prime of 3 is minus 6. What is g prime of 3? 5. So this is going to be minus. Now what about next one? So we have f g prime of 3. So in this case, we employ the product rule first. So we have f g f g. So first one is going to be f prime 3 g of 3 plus f of 3 times g prime of 3. Yeah. So now again, we have to substitute the values given to us. F prime of 3 is minus 6. G of 3 is 2. F of 3 is 4. And G prime of 3 is going to be 5. So what do we get in this case? Minus 12 plus 20, which is going to be 8. So far good. Now how about this problem? So f prime divided by g, f divided by g prime at 3. So again, here we have to use the quotient rule. So this is going to be g of 3 square, g of 3 as it is, multiplied by f prime of 3 minus f of 3 times g prime of 3. So let's get the values. So we'll get what this is going to be. G of 3 is 2. F prime of 3 is minus 6. Minus f of 3 is 4. Times g prime of 3 is 5. Divided by g prime, g of 3 the whole square. So g of 3 is 2, so 2 square. Now when you simplify this, what do you get? You get minus 12 minus 20, which is minus 32 by 4. That's gonna be minus 8. Okay. Now can we do this problem? So this is going to be f minus g the whole square evaluated at 3. Or if you want to write it in a, you can also write it as f of 3 minus g of 3 the whole square. Then you have here f of 3 minus g of 3 as it is, multiplied by what? Multiplied by f prime at 3 minus f of 3 times f prime, or you can write it as f minus g prime at 3. So let's see, what do we get out of this? So this is same as f of 3 minus g of 3 times f prime 3 minus f of 3 times f prime 3 minus g prime of 3. The whole divided by g of 3. Now let's plug in the values. What are the values? The values are f of 3 is 4. So this is going to be 4 minus g of 3 is 2. So this square. Then what else do you have? F times f prime 3. What is my f prime 3? F prime 3 is minus 6 minus f of 3, which is 4 times f prime 3, which is f prime 3 is what? Minus 6, and g prime 3 is 5. So minus 6 minus 5. Then the whole divided by f minus g the whole square, which is going to be 4 minus 2 the whole square. Okay, so these are the values, and now we need to simplify this. So let's simplify this. So we have 2, 4 minus 2 is 2, 2 square is 4, 4 times minus 6 is minus 24, minus 6 minus, so minus 11, minus 11 times minus 4 is plus, divide by 4 minus 2, which is 2, so 2 square is 4. So what do we get? We get minus, we get 20 over 4. Yeah, which is going to be what? Oh yeah, thank you. Numerator is not really squared. So this is going to be 2. So this is going to be minus 12. So that is going to be 32 over 4, which is going to be 8. Thanks. Okay, so this is the answer. So the answer is 8.